Hi everybody. So in this video, we're going to look at the benefits of using a normal distribution to approximate a binomial distribution. So a binomial distribution, especially for large sample sizes, can be difficult to work with directly due to the factorials involved in its probability mass function. The normal distribution provides a simpler, continuous approximation that is easier to work with, particularly for calculating probabilities. The second benefit is the availability of normal tables. So I showed you in a previous video where we looked at the standard normal distribution on how we can use tables to calculate probabilities. And these computational tools for a normal distribution are widely available and easy to use, regardless of how large the sample size is. Our third benefit is that the use of standard normal distribution in hypothesis testing is well established and widely used. This can be particularly useful in quality control, clinical trials, and other fields. Our next benefit is the confidence intervals. Calculating a confidence interval for a binomial distribution can be complicated, and it's much easier using the normal distribution. And the flexibility of a normal approximation provides a bridge to other areas of statistics and probability that might not be feasible with the binomial distribution alone. So now we understand the benefits of why we would approximate a binomial with a normal distribution. We need to understand the conditions of which we can do this. So the approximation works well when the sample size n for the binomial distribution is large. You can see in these two examples, the black lines represent the binomial data, the red curve represents the normal distribution, and you can see that when n is 10, so a sample size of 10, and a probability of 0.2, the binomial data is not aligned with a normal distribution. But when you increase the sample size to 50, keeping the same probability, you can see there's a much better alignment between the binomial data and the normal distribution. Another condition is that the probability of success needs to be approximately 0.5. So for instance, if we've got a sample size of 100 and a probability of success of 0.01 for this binomial distribution shown in black lines, you can see again it doesn't quite align with a normal distribution. It goes over here, but under here. And if we looked at the opposite case, where we've got a large probability of 0.95, now you can see the data is skewed in the opposite direction, where it goes over the normal distribution on the right side, but under on the left side. But in our third example, if the probability is 0.5 and we keep to the same number of trials, then you can see there's a much better alignment between the binomial data and the normal distribution. So what this means is, to approximate the binomial distribution using the normal distribution, we need a large sample size and a probability of approximately 0.5. We also need to consider something called continuity correction, and this is an adjustment for discreteness. The binomial distribution is discrete, meaning it only takes on integer values. The normal distribution is continuous. And continuity correction adjusts for this difference to improve the approximation accuracy. But to apply continuity correction, we need to consider the boundary accuracy. And by adding or subtracting 0.5 to the binomial variable, we create a closer fit between the two distributions, so approximated probabilities become more accurate. So in summary, to approximate the binomial distribution with a normal distribution, the sample size should be large enough, typically greater than or equal to 30. The probability of success should be approximately 0.5, and we need to apply continuity correction by adding or subtracting 0.5 to the binomial variable to take account for the discreteness of a binomial distribution. So I hope that's given you a clearer idea on the benefits of approximating the binomial distribution using a normal distribution. In the next video, I'm going to work through some examples with you using the normal approximation.